Now, dear students, let's start new chapter, chapter 5, work, energy and power, right? Now, work, energy and power, these are the physical quantities. Later on, we will discuss the definitions of these quantities and detailed discussion related to all these will be carried out. First, we will discuss the scalar product of vectors, right? In previous chapters, we discussed about vectors and we discussed that we have to study about the vector algebra. And in vector algebra, we have to discuss summation of vectors, subtraction of vectors and multiplication of vectors. Division of vectors are not defined, right? Now, in previous chapters, we discussed about summation of vectors and subtraction of vectors. Now, in this particular chapter, we will discuss about the product of vectors or multiplication of vectors. There are two types of multiplication of vectors. One that is the scalar product and another one that is the vector product. Let's first discuss scalar product of vectors. So when the product or multiplication between vectors is carried out in such a way that the result is a scalar quantity, then it is called scalar product of vectors. This scalar product of vectors is represented by the symbol of dot between vectors. So it is also known as dot product. Now, we can carry out the scalar product between two vectors, between three vectors, between four vectors. But here, we will restrict our discussion for scalar product of two vectors. Now, see here. Suppose we have two vectors, vector A and vector B. Suppose we represent both the vectors from the same origin O, right? Then, here we can see the angle between these two vectors is suppose theta, right? Now, how the scalar product between these two vectors that is defined? The scalar product between these two vectors A and B, that is defined as A dot B equal to magnitude of A into magnitude of B into cosine of the angle between these two vectors. Simply we can write vector A dot vector B, that is AB cos theta, where theta that is the angle between A and B. Okay. Now here we can see this thing. See, on right hand side here, A that is the magnitude of vector A, B that is the magnitude of vector B, and cos theta. All are the scalar quantities. So result of this one will be a scalar quantity. So we can say this is the scalar product of two vectors. Now here we represent it by the symbol of dot we discussed. So it is known as dot product also. Now see here. In this figure, suppose we draw a normal from the head of A to this vector B, as well as a normal from the head of B to vector A. Then we will get these elements OM and ON, right? Now see here. When we write A dot B, that is AB cos theta, then we can write this one as A dot B equal to B into bracket A cos theta. Clear? Now suppose we take here cos theta, right? Then we can write cos theta, that is this. First we take this adjacent, then adjacent upon hypotenuse. So adjacent is OM and hypotenuse that is magnitude of vector A. So we can write cos theta, that is OM upon A. So OM that is equal to A cos theta. Clear? So now here A cos theta that we can replace by OM. So we can write A dot B that is B into OM. It implies that we can write B that is magnitude of vector B and OM that is the projection of vector A on B, or we can say the component of vector A in the direction of vector B. Similarly, we can write A dot B that is A into B cos theta that is A into ON. So that is magnitude of vector A into projection of B on vector A. So now in broad sense we can give the definition of scalar product of two vectors like this. The scalar product of two vectors is the product of the magnitude of first vector or any one vector with the projection of second vector or other vector on the first vector or in the direction of first vector. So this one is the scalar product of two vectors. Clear to all of you?